Hello, I'm Kyle, and this is Prandal, and we're going to be presenting our project for the ECE Thread challenges in the Thread signal processing. So, what is our project? For our project, we decided to make a piano, but not just any piano that plays a boring singular frequency. We wanted to try and mimic a real-life piano and include a lot of those extra harmonics, as well as enclosure functions, which will help those frequencies decay versus time.
So the primary electrical components that make up this project are the daisy-seed microcontroller, which is used in the audio lab to actually facilitate a lot of the audio applications. The second is a speaker, of course. The third is a TL071 op-amp that actually allows us to crop the signal values for the voltages to reasonable values that allow to actually transfer to the audio amplifier well. Then, of course, the LM386 audio amplifier for providing power to the speaker that's in a ratio proportional to the signal voltage going to it. And finally, there's a lot of other passive components, including buttons, resistors, capacitors, and the protoboard to actually put our complete application together. So as you can see, this is the schematic of our entire application. So there's the daisy seed that's hooked up to all of the digital inputs from the buttons. And then there's one final analog output that goes to the speaker driver circuit, which includes an inverting op-amp buffer that's isolated on both sides, and then that goes to the audio power amplifier, which finally powers our speaker.
Cool. And now what you've all been waiting for, a little listening test of the piano. But first, we're going to play some pure tones, so you can all get a listen on what a pure sine wave sounds like, and then we can compare it to our project, and you can really hear those harmonics ring through. So this is a C4 or middle C. All right, and now we actually get to play the piano. So as before, we had a middle C. This is the middle C on the piano, and we can get a good listen to it now. As you can hear, it's decaying over time, and that's part of our envelopes that we have, as well as, listen again, it sounds just a little bit brighter, and that brightness comes from all the harmonics that we added into just the root fundamental. So now we can demonstrate playing every note up for a full octave. That's one octave. And not only can we play single notes, but we can play full chords. And not only can you play chords, but you can play a full song if you really want to as well. And an LS setup allows us to also play multiple presses and hold them out too, without any trouble.
So here is a full overview of our entire setup. So first, there's the two batteries, the two 9-volt batteries that are in parallel, and that allows to have more current and more power to our speaker. This feeds in directly to the audio amplifier circuit, which the daisy seed, the microcontroller, also feeds directly into. The daisy seed also has all of the button inputs going in that allow to know whether a button is pressed, and then it sends out its analog signal to the audio amplifier, which then is passed on to the speaker. Now, if you look at the actual hardware setup, you can also see buttons hot glued on for each of the pads, each of the keys, and specifically, each of the buttons are catted in a way that allow them to spring back up after being pressed. And there's a specific pad at the bottom of it that then presses down on the button, as you can see here, pressing this A sharp. That actually allows it to spring back.
Thank you all for watching. Marco is unfortunately at an interview at SpaceX and cannot do